Hey there, science fans. Have you ever wondered what makes your smartphone so smart or your computer so, well, computery? The answer is hiding in plain sight semiconductors. Semiconductors are like the secret source of modern electronics. They're these tiny materials that can conduct electricity, but not as well as metals like copper. That might not sound very exciting, but trust me, it's this in-between nature that makes them so special. Without semiconductors, we wouldn't have smartphones, computers, video games, or even the internet. They're the unsung heroes powering our digital world. So let's dive in and explore the amazing world of semiconductors. Now, imagine a piece of pure silicon. Silicon is a semiconductor, and in its pure form it has an equal number of electrons, which carry negative charge, and holes, which act like positive charge carriers. Think of it like a dance floor with equal numbers of boys and girls. Everyone has a partner and no one is left out. This balance is what makes pure silicon a poor conductor of electricity. But here's where things get interesting. We can actually tweak silicon's conductivity by adding tiny amounts of impurities, a process called doping. It's like adding a few extra boys or girls to our dance floor, creating an imbalance that makes things much more lively. Let's say we add a pinch of phosphorus to our silicon crystal. Phosphorus has one more electron in its outer shell than silicon. This extra electron is like the new kid at the dance who can't find a partner. This free electron can easily move around, making the silicon a much better conductor of electricity. We call this N-type silicon because it has an excess of negative charge carriers, electrons. Now, what if we add a bit of boron instead? Boron has one less electron in its outer shell than silicon. This creates a hole, a missing electron that acts like a positive charge. These holes can also move around, making the silicon more conductive. This is called P-type silicon because it has an excess of positive charge carriers, holes. Dean. Now for the grand finale. What happens when we join a piece of N-type silicon with a piece of P-type silicon? We create a PN junction, the basic building block of diodes, transistors, and integrated circuits. At the junction, the free electrons from the N-type silicon are attracted to the holes in the P-type silicon. This creates a depletion region where there are very few free charge carriers. This depletion region acts like a barrier, preventing current from flowing easily. However, if we apply a voltage in the right direction, we can overcome this barrier and allow current to flow. This is how diodes work. And that's just the beginning. By combining PN junctions in different ways, we can create all sorts of amazing electronic components that power our modern world. So next time you use your smartphone or computer, remember the tiny wonders inside, semiconductors, the unsung heroes of tech.